Look closely at our planet. Every single moving part of this biological and atmospheric engine runs on a single fuel source. The sun dictates our planetary climate patterns, pushes ocean currents, and feeds the very bottom of the biological food chain. Without that steady stream of solar energy hitting the surface, Earth would rapidly grind to a halt, which raises a truly terrifying question. What would actually happen if our star simply disappeared entirely from existence? This spatial map illustrates the massive scale of our solar system. To understand how we'd experience this event, we have to track the speed of light. It takes exactly 8 minutes and 20 seconds for a photon to cross the 150 million kilometer gap between the Sun and Earth. That creates a bizarre physical time lag. For over 8 minutes after the Sun vanished, we wouldn't notice a thing. People would keep driving to work, birds would keep flying, and we'd continue our routines in complete ignorance. The bright sphere we see in the sky is actually a phantom, a snapshot of the past. If the sun went dark, we would spend our final moments living under the light of a ghost, entirely unaware of the invisible ticking clock. When that 8-minute countdown hits zero, the physics catch up to reality. The daytime sky instantly turns black. Even at high noon, Earth plunges into sudden midnight. But light isn't the only thing traveling across that gap. According to general relativity, gravity propagates at the exact same speed. When those final photons arrive, the sun's gravitational hold disappears right along with them. This map shows how Earth relies on the sun's mass to stay in its elliptical path. Without that tether, our planet stops curving and slingshots out in a straight line. Unmoored, Earth drifts entirely alone into the frozen void of the galaxy. You might expect the planet to flash freeze immediately. Fortunately, our massive oceans and thick atmosphere act as gigantic thermal batteries. They hold enough stored heat to keep the surface physically survivable for the first few days. But that residual warmth is a temporary buffer. Once that thermal battery drains, the true physical collapse of the planet begins. The biological crisis strikes first. Within a week, the total lack of sunlight shuts down photosynthesis, causing plant life across the globe to rapidly die off. That triggers a devastating chain reaction. Herbivores quickly exhaust their food supplies and starve. With the prey gone, apex predators soon follow, unraveling the entire planetary food chain from the bottom up. This chart tracks surface temperature as heat escapes into space. By year 1, the global average falls to an unlivable minus 73 degrees Celsius. At these extremes, cities become frozen ruins. Surviving outdoors is impossible, forcing humanity to retreat into deep underground bunkers. Down in the oceans, a different thermodynamic process takes over. Because water holds heat efficiently, the immense volume of the sea resists freezing all at once. The oceans freeze from the top down. An expanding crust of ice forms across the surface, which actually acts like a massive thermal blanket, insulating the deep, dark liquid water flowing beneath it. The top layer of the Earth effectively locks the deadly cold out. While the continents become a barren wasteland, that miles-thick sheet of ice inadvertently builds a protected sanctuary far below the waves. From the outside, our planet now looks like a dead world, a silent, ice-encased sphere drifting quietly through an endless night. But deep inside this frozen capsule, biological activity continues. On the pitch-black ocean floor, hydrothermal vents spew superheated fluid from the Earth's core. This heat supports an alien ecosystem. Extremophile bacteria pull energy from chemical reactions, bypassing photosynthesis entirely. Deep-sea colonies could survive here for millions of years, oblivious to the missing sun. Fortunately, we don't need to worry about retreating to the ocean floor anytime soon. Astrophysicists assure us that our star holds enough hydrogen fuel to keep burning brightly for another 5 billion years. But knowing exactly what would happen without it gives you a stark new perspective. Tomorrow morning, when you see the daylight break across the horizon, remember it is the fragile anchor keeping us from drifting into the dark.